Welcome to my wonderfully ghetto model of the nebular theory. I hope that this helps at least some of you, though. I feel like it will. For starters, let's just recall and back up a little bit exactly what the nebular theory is based off of. The nebular theory is based around this idea that our whole solar system first began with a nebula. Nebula should sound familiar from when we were talking in the star life cycle because they are also the first phase of what stars. We're just going to be talking about what is not just happening with the star, but what's happening around the star as well. All right, so pretend that what you're seeing here, that this is a nebula. Remember, a nebula is a large cloud of gas and dust. So let me break down kind of what I was imagining when I looked at this. The paper, everything that you see here, the paper, this is going to represent our gas. A lot of nebulas, they're made of all sorts of different materials, but primarily the thing that mostly makes up a nebula is the element hydrogen. These are basically large clouds of hydrogen. But there are some other materials in here because they're called clouds of gas and dust. So what's the dust part that's in here? Well, if you could look closely in here, you'll see that I actually have a few little flecks of metal that I've also put in here. So this metal represents the dust that's in there because the dust that makes up these giant clouds is actually things like metal and rock and other things like that. Everything that's basically not a gas. Now, before we proceed, I really just want to drive home this idea. Everything that you see on our planet, whether it's plastic or whether it's the metal and the elements that make up your electronics, or even the things that make up who you are, everything that is on this planet was once here in this nebula somewhere. If it was not here, then it was not on our planet in the end. Even the gold that's in my ring, all of that was once just floating around as tiny little parts in this giant nebula. So what happens? How do we go from this into an actual planet in a solar system? That's what the nebular theory tries to explain. So here's the first idea with the nebular theory. First, you need to start with a large cloud of gas and dust, like this. But now here's the thing. As small as each and every single one of these are, they still have gravity, which means that this little guy has a gravitational force on him and that he is having a gravitational force on this one, which means that over time, these two things are wanting to be pulled together. So the first thing that happens in the nebular theory after the nebula phase is that through gravity, all of this slowly starts to clump together. And that as it clumps together, it gets more gravity, which pulls in even more stuff, which pulls in even more stuff, until slowly, in the center of the nebula, you build up this really hot, dense center of material. Eventually, ding! Eventually, all of that really dense material starts to consolidate into one solid mass that really starts to get a lot hotter than all of the surrounding areas. This is what will eventually go on to become our star. It's mostly made out of hydrogen, as it just took all of this hydrogen in, but it leaves some of the material around. It doesn't quite pull in everything. It leaves some of the material around the edge of the star. Now, here's the thing. The next phase, after gravity causes all of this to collapse together and build up this really, really hot, dense center. The next phase is the ignition of fusion. What happens here is that inside of our star, it begins to take atoms, slamming them together and permanently fusing them together, if you can remember that from our last little activity we did. Once it starts to do this, this is releasing tons of energy. It literally is like a bomb constantly going off, so it gives off that energy. You and I, we see that as the form of energy of just light, but there's another form of energy that this starts giving off. And it's given off in the form of something called the solar winds. The solar winds come off from the surface of the Earth and literally have the ability to start moving some of this material. So when our star ignited, this is pretty much what happened. Just watch. The solar winds took all of the remaining gases that were still close to the star, and because they were so much lighter and denser, they got blown away to the outer edges of our solar system. But the things that remained behind was all of the metal rocky material. So now I want you to think about this. What material are all of the inner planets made out of? What material are all of the outer planets made out of? Does it make sense now why all of the inner planets were somehow coincidentally the rocky iron material or metal material, and all of the outer planets were the gas and ice planets? It's just because this material is lighter and denser, so it got blown away by the solar winds, while all the material that we're made out of is all the rocky heavy material. But now, looking at this, how much material is there of all of the gas and the ice that's out here? And how much rocky and metal material is there? There's not really a lot of this. So what ends up happening is that over time, the next phase is called the accretionary phase. To accrete means to build. So what we are building here is we're slowly building the planets. That as these move around, and I wish I could move these around easier, but as these move around, gravity, because they're moving, they don't get pulled in towards the sun, but because of gravity, all of these start to clump together. And these are what form the planets that are closer to the sun. What little bits of gas did remain get pulled into these planets. This is what happened with Earth. We were big enough that we were able to hold on to some of the gases that we have here. So not all of the gases were able to be blown out. We were able to hold on to things like oxygen or carbon dioxide or nitrogen and things of that nature. Planets that weren't so big, though, weren't able to hold on to some of those. So some of the planets that we have don't have some of those things. But you have all of these inner planets that actually form around the stars that are generally the rocky planets. There's a certain point that surrounds out here that's really important. It's this part right here. Forgive me, I know this isn't going to be my famous perfect circle that, yes, is still on my board at the school. But there's a famous point right here called the frost line. What's significant about the frost line is that this is the part of space where the gas gets far enough away from the star that it actually is cold enough to start freezing. It's cold enough to freeze gas. It's a couple 100 degrees below Fahrenheit. It's really, really, really cold out here. But as the gas starts to form into solids, what that means is that it's again easier for it to actually start clumping up. But because there is so much material that you have out here, the size of your planets that you end up making end up being a lot bigger than your inner planets, just because you have more building material. And over time, as all of these planets go around our sun, their gravity pulls in all of the remaining little rocks and gases and other things of that nature that are just hanging around the solar system. And that is the idea of how our solar system formed. That we started with what was this just really unorganized mess of material in the nebula, through then, with gravity, bringing all that material together to form a star in the center. Once that star formed, a lot of the gases got blown out by solar winds past the frost line, where they were then able to freeze. And the next part that happened in the accretionary phase was that all of the planets that didn't have the material pulled into the star were able to clump together and actually form the planets that we see today. Because there was fewer rock and metal material, all of these planets end up being a lot smaller. Because there was a lot more gas and ice and things of that nature, this material out here was able to make bigger and bigger planets. And that's the rough idea of how the nebular theory works and how our solar system came to be.